Okay, guys, good morning. Welcome to MongoDB Local. We are so happy to have you over here at the Bryant stage for Chai and Chris. They are talking about the analytics Jumpstart, right? Enhancing your ability to discover critical insights with your operational data. Chris and Chai are both solutions architects here, located in New York. Chris, like Chris, Chai, like the tea, right? Welcome them up to the stage. Woo, 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 woo. And we will have about 10 minutes for questions, but please hold them. Everybody, Chris and Chai.
Thank you. All right. Welcome, everyone, to MongoDB Local. We are here with the Analytics Jumpstart. Broadly, we're going to be talking about how to get analytics outside of your operational data. So we know MongoDB today is great at high transaction, high throughput querying and high throughput inserts, but we really want to think about how do we get closer to our data, closer to the insights that we're trying to drive for any analytical analysis that we want to put on put in front of our customers. So just as a quick introduction, my name's Chris King. I'm a solutions architect at MongoDB. I've been here for about a year and a half. I work with clients all across our different verticals, financial verticals, applications, small apps, large apps. But in prior lives, I ran a business intelligence team building data pipelines and analytics for enterprise-grade customers.
Awesome, thank you, Chris. Well, I just want to say thank you, everybody, for just being here early and joining us here in New York City. It's awesome to have everybody all over here and looking at the energy. It's just awesome. My name is Chaitanya Varanasi. I go by Chai, like the tea, and I'm a senior solutions architect here at MongoDB. I've been with the firm for roughly 3 years now. I primarily specialize in financial services. That's the type of clientele that I work with. But before that, I was in observability, and before that, I was a software engineer. So Chris and I are very excited to lend our experience here for you guys here all together. Let's get together for an hour, get the bright and early morning, and then we'll learn about analytics together. So I just wanted to go ahead and start by setting the stage a little bit, right? This is the landscape that we're in today. Like, you look at your typical startup, you look at your typical Fortune 500 company, your typical Fortune 50 company, wherever it might be, you typically see two different distinct types of teams. Developers are mostly responsible for, production code, pushing like features against a Scrum, going ahead and interacting and developing features for thousands of users to go ahead and consume low latency queries. On the other side, you have your analysts, which are your data scientists, your data analysts, sometimes a little bit more business facing, right? You're responsible for probably building insights, dashboards, to go ahead and govern and define decisions that might happen maybe a year to 3 years down the road, sometimes maybe a month. It's all kinds of like different decisions and dashboards that you're driving. But a couple of things we can take away. It's usually a separation of domains. There are different teams that go ahead and do different audiences. One does probably heavy duty reporting, whereas the others are more nimble and light. Now, we've kind of talked about the folks that are involved in the equation right here for analytics. Let's talk about some of the demanding requirements that products and applications need to go ahead and really succeed in the market today. Number one is, kind of the most important to me, it's live app data. So you don't want your app data to be stale. You don't want it to be low. You want it to be very, very fresh. A great example of this is a taxi, right? I want to go ahead and order the taxi right now, and guess what? If I don't get the latest pricing data, then I'm going to be very, very annoyed, because then I might have to go through a massive charge later down the road or something like that. So it's very important that my data comes to me and it's very fresh. The second of which, the results of any decision making or any analytics have to be delivered to me or the customer within a second. Now, humans are very impatient. It's kind of who we are, right? We notice latency sometimes when the app is even behind by 50 milliseconds. It has to be in the app flow. Now, it's not just about all of us here in New York City. It's not about just me as well. The app sometimes has to support millions of concurrent users, right? That's where it really has to operate at scale with elegant automation. You have to have queues and load balancers and all the necessary infrastructure to go ahead and support to get your analytics over to the customer by itself. Now this is, if we are taking our process and we're taking our requirements and our people, let's kind of go a little bit from a 50,000 foot point of view over to a 20,000 foot point of view, right? We see that demarcation over in two different places. We see a centralized analytics team, and then we also go ahead and see applications like developers working on microservices and pods and whatnot. But in the middle, there's a certain tax involved, right? It's a streaming tax. So you have to typically ETL data that you take from your centralized analytics and then take it all the way over to the application. Now, with the centralized warehouse or any sort of application there, you're typically scanning billions, millions worth of records. However, what if you could go ahead and kind of shift that? What if you don't have to rely on your centralized analytics team for everything? What if you don't have to bring back all of the data and you can keep it fresh, right? Because that ETL, it takes several minutes sometimes, it takes several seconds sometimes. Even with the latest streaming technologies and the latest data warehouses, it takes a lot of time. So let's go ahead and examine a new paradigm where shift a little bit, where maybe all the developers and all the analytics teams can kind of work together, and let's take that diagram and shift it left. So what does this mean, right? So to overcome the challenges, the analytics team, we basically go ahead and offload some of that processing over to the application. We call that application-driven analytics. Now, we're not trying to be the data warehouse, we're not trying to be your analytical team, but the goal here is to minimize the ETL and do what we can on the application, on the pod right there. So you're not scanning now millions and billions of documents. You might be scanning thousands and millions of documents instead. It's more local to the user, it's more local to the application. They're working with data that is relevant right now, rather than from a bunch of disparate sources right over here.
So to illustrate this concept, let's think about building a sample product. So we came up with this company, M Energy. Basically, think about it like a home energy management company. What we do is we will take data from tons of different sensors around many different households and persist that data up to the cloud so we can actually share it with energy companies and bill pay companies to make sure that we understand the reporting. So if we start by thinking about the business requirements for this kind of use case, we know that we need high throughput transactions, right? We have millions of households sending millions of data points every hour, every minute of every day. We also need real-time insights, things like tracking outages, understanding where we're having region energy bursts, right? Understanding in near real time what is going on with the sensors that we're actually tracking. Lastly, we need to be able to persist the data lineage for historical data, compliance data, bill paying, and we need to visualize this data in an elegant manner so anyone trying to consume this data is going to be able to understand the insights that we're getting out of it. So as a high-level architecture that we could think about building for this, as our data producers, we have locations and sensors. So think of this like millions of households scattered around the United States, that each of these households has 10 to 12 devices that are actually producing data every minute, second, or hour. All of this data is going to be streaming to MongoDB Atlas and being able to be utilized in a way that we can report on the data, generate bills, and then lastly, our data consumers, right? What we want to build, we want to give our internal people a web UI to understand where we have outages, regional failures, where we have people looking at trend analysis, as well as our data science team. And lastly, we also need to support billing use cases. So we have a little bit of analytical use cases, we have a little bit of functional use cases as well. So diving into the first requirement, we need to think about how do we support this high throughput and efficient storage with the amount of data that these devices are actually producing. So let's break down managing large data. All right, again, millions of devices sending data. This is happening from everywhere. We need to be close to the source of the data and be able to write it to our database efficiently. We have second level granularity. So the amount of data points that we are sending from these devices is incredibly high. If we think about the way that we're actually querying the data, we need to be able to manage these patterns very easily, right? We need to look at window functioning. We need to look at the last month of outages or the last year of outages. Then we also need to think about storing this large amount of data, right? We're not just storing the data for the month, we're storing it for the year and even past that. So how are we going to keep these billions of ticks that are coming through our sensors efficiently? And lastly, we need to aggregate and support grouping and windowing on this data so that we can actually effectively generate the insights. So if we think about what a device payload looks like, right? Every device is going to have a sensor ID, denoting the sensor that is coming, the specific sensor that's sending the data. We also have a timestamp that's going to denote what is a window of time that we're actually making the measurement of this data. We also have our devices are registering with a household, so they have things like an address, they have a city, a region, a household ID, as well as a couple of more measurable metrics such as an outage meter to denote if the device is experiencing an unexpected outage. And lastly, we are tracking a measurement, more of a metrics-related field of how much energy have we consumed within the amount of time that we are sending this data. So there are a couple ways to attack this pattern, right? One of the first ways that might be the most obvious is, hey, let's just submit a document every single time a device makes a measurement, right? We send all the metadata, we send the device ID, the household ID, and we track the amount of kilowatt hours. So some of the benefits here are that we are able to support simple CRUD operations. Our inserts are very efficient, our finds are very efficient. We can end up interacting with the data very easily. Also, the storage pattern is incredibly obvious, right? We know that every document is independently a measurement that we have on this data set. And again, the ingest rate is incredibly high. But as you can probably see, we are duplicating a ton of data, right? We are sending the same household ID every time one of the 12 sensors actually sends a reading. And it's also more difficult to answer those aggregated questions that we want to get out of the data. So let's look at another pattern. What we can think about is bucketing these measurements together, really reducing that data duplication. So the idea of bucketing is going to be very efficient for storage, right? We're just tracking the specific measurement ticks under the hood. We're able to answer these aggregated questions because we are already aggregating it aggregating up to the top level of a timestamp and a sensor ID. We can also do things like compute the average of that timestamp ID. Now, additionally, the metadata is not duplicated across many different data points. So again, it's efficient for storage. But the trade-off there is it is difficult to query because we're dealing with arrays now that are of unbounded length, and the data model has to be managed by the application. So when we think about inserting a new measurement, we have to find the specific measurement ID or sensor ID and timestamp that is going to take that measurement, and we have to insert it into the correct place. So this is all managed by application code as opposed to the database. So what if we thought about taking the best of both worlds? Maintaining that we want to make sure that we have an easy to understand data model. It's simple to insert all of the data into the database. We can understand it and also support those simple find queries, as well as optimize all of this data for storage, right? So this brings us to thinking about time series collections with MongoDB that were introduced in MongoDB 5.0. We have native support for this, but I'm going to transition to Chai.
Thank you, Chris. Right, like we saw a couple of the efficiencies, right? Like we want to take advantage of bucketing. We want to take advantage of the ease of singular measurements. But now let's kind of dig into a little bit of, okay, let's put our foot actually on the ground and let's go ahead and walk through some code samples. So in front of us, it's just very easy on how you go ahead and create a time series collection here in MongoDB. Keep in mind, this exact command right here, you don't need to create a separate time series cluster for temporal expressions. You don't need to go ahead and even spin up like a whole nother EC2 or a whole nother VM, whatnot. You can actually go ahead and within your existing MongoDB cluster, create a time series collection. So the first piece of it here, let's walk through all the fields together. Time field is your timestamp. What time does the record come in? Now MongoDB has many open source drivers. I'm a Python guy, so I'll just kind of use that example. So I can go ahead and take my PyMongo, my exact datetime object, and plug it into the time field. So here I'm going ahead and maintaining a level of precision as well. Second of which, there has to be some sort of unique identifier that goes ahead and tags the data. Now with your traditional MongoDB collection, we have our underscore ID. It's automatically gone ahead and created. So in this case, a lot of our drivers go ahead and create the time series record with an underscore ID as well. However, you don't explicitly need it. You can have, in our example, in our product, a sensor ID as the primary key. Next, we talked a little bit about the bucketing patterns, right? We want to go ahead and be able to adjust the level of granularity. All those singular branch elements that we're going ahead and sending in, they need to be able to be grouped together into a granular bucket. So today, for our use case, it's an IoT use case. Let's go ahead and set it in the seconds. And next, last but not least, this is a nice little tidbit and an important one right here. It's the fact that you don't have to build your own TTL mechanism, time to live. I don't have to build an archival function. Instead, my temporal expressions come with a expire after seconds. So for the math whizzes out there, we're just really translating this to 24 hours in seconds. Now I can keep this longer, I can make it shorter, I can adjust the time, but the fact is that after X amount of seconds, the data will get deleted automatically for you. This is another example of how easy it is to go ahead and insert a time series record. Now keep in mind that look at if you read the two details and kind of the timestamps right there, we're inserting them as singular measurements right here, simply just as the sensor readings. We're not having to go ahead and push them into specific buckets. So what does this mean to an application development team? That means they're not really pushing into specific arrays. They're not going ahead and maintaining multiple lists. You don't need to maintain the live bucket at the time. You just go ahead and spin up and create individual sensor readings and send them into the cluster. I also want to point out one little kind of tiny thing right here. Notice that the schemas are not the same here. The top one has KWH and the bottom one has a sensor. So this really resonates with one of our core principles of kind of what got MongoDB started, which was developer productivity and the document model. Schemas do not have to be symmetrical here. Each type of data they can mix and match together here as well. Like my EV maybe doesn't match up with Chris's like energy consumptions, or his EV doesn't match up with mine. We can have different types of records all together. Now it's really extremely easy to query as well. We're not having to unroll buckets. We're not having to go ahead and unwind different arrays. We're not doing any of that. Instead, when I go ahead and give in a primary key, or if I go ahead and do a find, all that's returned back to me is singular documents. So instead, if you're doing an event-based API, if you're going ahead and ingesting different events or different records, you don't have to do all that computation. MongoDB is going to go ahead and do that for you. Now, we've talked about a lot of this, and remember, one of our requirements was high-level storage, right? So if you go ahead and take that into account, we have a very, very key driver here, which is called columnar compression, right? It gives you about 70% benefit in storage, about 100x smaller indexes right here to go ahead and take off of. And the second of which, the primary benefit to you, leaner and meaner memory caches, better and more performant collections. So we're taking into account all of the compression algorithms that you know, like delta on delta or delta. We take into the assumption that time series, for example, the data is relatively static, doesn't have a ton of variations. So we can take the delta of those records. Makes it very, very efficient. So I'll give you a quick example. When we went ahead and we built out our cluster, all of our sensor readings together were roughly around like 200 gigabytes. If we put them in a traditional MongoDB collection, that data gets compressed down to 15 gigabytes. Awesome kind of leverage right here, right? 200 all the way to 15. But we can take it one step further and apply columnar compression to it, and you end up all the way with 10 gigabytes. So that's a huge level of saving when you come to storage economics and database economics right here. Now think about our product, right? We know that it's easy to query, comes back with singular measurements, easy to store, a little bit of 70% like worth of savings right here. And then we also know that we can support highly concurrent users and highly concurrent transactions at the same time, which is what analytics is all about. Now I want to take it a little bit more. We've talked about simple querying. How do I get back and forth from the database right here? But now I want to go ahead and approach a little bit more advanced querying. Oh, excuse me. Mind going back one back? Okay, thank you. So we have a couple more requirements right here as we go ahead and build out the product. We have multiple stakeholders coming to us and they're saying, I want to go ahead and build out a billing and reporting service. I want to go ahead and build out a full analytical dashboard for myself right here. A data science team is coming to me and saying, well, we need to go ahead and understand what are the surges, what are the outages, what is going on right now in real time. So for that, I would like to go ahead and introduce a concept called window expressions. So it's basically how you go ahead and run analytics over a flexible date range. So temporal expressions, they're very, very easy to go ahead and work with. So it's basically working on pre-sorted data, and you can go ahead and apply existing computations to that data. Now, what would happen if you didn't have window functions? You would have to maintain the date ranges manually in your application code. You would have to go ahead and basically trail those windows over by yourself by defining and manually adjusting those ISO date stamps. So let's take a look at this code example right here. I'm partitioning by the device ID, so my particular sensor ID. And then I'm going ahead and applying a computation with an integral function. So all the values, I'm applying them, I'm summing them under the curve, and then I'm applying a window for everything in the last 1 hour. So I can just do -1 and then current. And this will be a rolling window that I can go ahead and apply that computation live. Now keep in mind, I don't have to go ahead and write custom code over to an analytics system. I can go ahead and do this directly on my application, directly on my microservice. So we've been kind of building out our product, a little bit of a teaser right here. So this is an example, right? We have an address, we have 10 sensors in a household. It's a very easy way for us to go ahead and build a UI, where in this case, we're tracking the number of outages. It's no outages, so we're okay. But still, it's from just an API call with a function, I can go ahead and relay this back over to the product.
So we've really covered a lot of, hey, how is my application going to talk and process some of this data analytically? But what about those users who are not actually coming from the application? We want to talk about ad hoc data analysis. We have data engineers who want to interact with this data and build data pipelines out of it, right? I mean, I think this is a quote, at least I can resonate with. A data engineer is coming to me, I want to get my data out of MongoDB. I may not necessarily have the toolkit to do this. So what are a lot of the challenges that we see working with multiple data sources, right? We have barriers of entry to data. We have multiple different systems that we're trying to query. We need to centralize it all in the same place. We may not have the access control. We may not have the know how to actually query and then merge that data. Which brings me to kind of the second point. It's incredibly complex to manage all of these different systems to query data together, especially when we're talking about real-time insights. You have to manage ETL pipelines, maintain those pipelines. If data changes, you have multiple places to change them in different contracts that you make via the APIs, as well as just functional contracts between teams. And lastly, all of this incurs inherent cost in managing multiple systems. Not only the infrastructure cost of duplicating data, but also the cost of maintenance, the cost of the right skill sets to manage a MongoDB instance and a S3 instance, and another AWS Redshift instance to end up getting all of that data in the same place. So one of the ways that we actually attack and think about the way that we can solve this problem is through Atlas Data Federation. Now to bring it back to our use case that we are talking about right here, we think on the left side of this screen, we have our data producers, right? This could be our time series device sensors. It's writing to the MongoDB cluster very fast, very efficiently. This is one source of data that we're actually looking at. Now additionally, we also have a product called Atlas Data Lake. From here, we can think about the automatic TTL of data to be able to archive it into a colder data store, but maintain queryability. So think about it like we need to access our old bills. We don't need to access them often, but for any remediation, we may need to come back and get it. How do we maintain queryability over time? And not only just for bill access, but think about trend analysis over time. We want to predict a region's future energy consumption. we need to access across multiple of these data stores without incurring a large cost of storing it all hot. Lastly, we have our own buckets. Now, in our use case, we are not thinking about storing data in our own buckets asynchronously outside of the time series, but we do have the option to store data in our own buckets and enrich the data that we're actually getting from or querying. But this all comes together with Atlas Data Federation, which is a federated endpoint to query across multiple collections without any other setup. So once we've configured the data sources, we are able to access an endpoint similarly to how you are accessing your Atlas cluster and query this data from these multiple data sources. So what that means is that all of the compute processing is going to be taken off your plate to be able to merge and do aggregations on this data to then persist to your data consumers. These data consumers could be back to S3, could be to another Atlas cluster, back to Atlas Data Lake. We could also do things like direct query from our application. We also, and in a second we'll talk about our Atlas SQL interface, the ability to run SQL queries on this. And what we've used in our application, Atlas Charts, the ability to actually visualize and look at trends of this data that are coming from our database. So let's talk about the data analyst problem, right? We know, all of us I know here are MongoDB and MQL experts, but we still have those laggards who are still working in the SQL world. And specifically data analysts who pretty much talk that language day in and day out. We don't want to be managing the export of data from MongoDB and writing MQL on behalf of people who need to be closer to the data. So what we would have to do in the typical world is build an ETL into a data warehouse, duplicate that data, and then provide that interface to connect to a JDBC driver so that we can give access to relational-based tools like business intelligence tools, or just our analysts who need to drive insights out of that data. This results in a very poor experience. We have we have slower time to insights as we have to move data from one system to another system. We're working on a lot of non-differentiating coded work. Think about building ETLs, maintaining infrastructure, and the analysis is not going to be on live data, right? We need to know if an outage is happening in a region now. We don't need to know tomorrow if this is happening in the region. So the solution here is the Atlas SQL interface. It is a hosted JDBC connector that can connect directly into your Atlas data via these federated endpoints. It's incredibly easy to get started. It has a direct connection to Atlas, and you're always querying the live data. Furthermore, as we think about the application writing to our production nodes, we can also spin up a non-production analytics nodes that are getting analytical node that is getting the real-time insights from that data via the replication of the data in between nodes. Now, what does this result in? It results in giving our analysts a place to work in the area that they are used to working in. So what we're looking at right here is an example of just a SQL query that is running on our NoSQL database and simply just grouping the data beyond on a household ID to group all the sensor ID and understand which devices are consuming the most energy. Now, the important thing here to note is we are SQL 92 compatible, so you should be able to have your data analysts be able to speak this language. Lastly, I would be remiss to mention or not mention that we don't have the concept, or we do have the concept of materialized views. So if we do have to do those complex computations that we don't want to pay the latency tax of aggregating a ton of data together, we can pre-aggregate into less demanding times on our server and write that back to our cluster in a materialized view to allow our end data readers to, or data consumers to read that data.
Now, it's a little bit unique, right? Our folks are coming to us and they're like, well, it's not just enough that you build out a product. It's not just enough that you build out a storage solution. Now they're like, well, I want to know everything about it. I want to know everything about my platform right here. So let's go ahead and introduce some more requirements into our product. Now, Chris doesn't care about my energy usage. I don't really care about his energy usage, but we both each would like to know in our dashboard what is relevant to each other. So we're introducing an idea of role-based access control. We want to build out data and dashboards that goes ahead and maybe needs to be lived ephemerally or maybe in a long-standing pattern. Our customers want to go ahead and highlight trends. What are the outages that I'm seeing at what time? Maybe my EV has been consuming energy a little bit higher from 2 a.m. all the way to 4 a.m. But we also need to showcase that full data and not necessarily something that is sprawled out to the entire customer, but just really in a condensed manner. So a couple of active requirements as I go ahead and introduce Atlas Charts. It was born in the document model and it was born with JSON, right? So a lot of the little sensitivities that you see with JSON, asymmetrical schemas, maybe an embedding pattern versus a referencing pattern. Charts is aware of all of that. We have automatic operations, so we can do pre-filters, pre-aggregations, and we can go ahead and deliver that data to you pre-transformed. Since it's all integrated with Atlas, you have no ETL. You don't have to go ahead and mix and match different systems together. It's almost a very, very simple setup for yourself right here. As a matter of fact, Atlas Charts is also integrated with Atlas Data Lake. It's integrated with our temporal time series collections. It's integrated with our traditional collections. You can merge all sorts of data in to Atlas Charts. Now, from a development standpoint, you want to go ahead and kind of mention that, hey, I need to get these dashboards to my users as easily as possible. So in a couple of examples we'll show you, we incorporated a React SDK and we're able to take the chart ID and boom, plug it in. So it's very, very easy to go ahead and embed on an iframe or an SDK. And sometimes keep in mind, they don't have to be long-lived charts. It can be ephemeral events as well, like an outage, for example. And then last but not least, it's very, very easy to collaborate. Because I have a level of role-based access and security, I can go ahead and share my chart to the individual users that need to go ahead and go to, or my data scientist team can go ahead and collaborate on my visualization tool. So I want to go ahead and transition into Chris, and he'll walk you through the demo and the UI that we built out.
So let's take a look at our final product that we've actually built. We talked a lot about the business requirements, what's needed from a home energy company to do detailed analysis on all of the devices that we're tracking, right? So like Chai said, we used our React SDK, our Charts SDK, to be able to provision things like authentication to the specific charts, data access control, put it behind that level of authentication. Also to provide filtering on these charts. You can see in the top left, we're able to filter by region, and this is going to filter down to all of the houses that we have in the East. We can understand things like households under management, right? A group of all of the households that we are actually tracking devices in. We have a kilowatt hour % energy capacity, right? We're tracking what is the sum of those devices that are being used in a certain region. We have a map to show where all of the households that we're tracking are. And lastly, we have a trend chart over time that is going to show us what is the energy consumption by device that we are tracking. Now on the second page of our UI, we're leveraging the window functioning capability. We're looking at the outages per month, right? In the prior month, how many times have we had an outage and where did this outage occur? So the second thing we're looking at is the outages per year. We're tracking over that period of time, a sliding window, how many outages have we had per year. This can be incredibly helpful for the quality metrics that we actually needed to check. All of this was built via a very simple React app and the charts embedding into the React app, and those charts are refreshing every 10 seconds to the live data that is actually coming through without any need for an ETL into a BI tool, without the need for multiple systems that are working together to build these kinds of charts. So if we think about kind of what are we taking from here, right? The important thing that we want to discuss is that we want to help you evaluate what the right tool is for the job, right? There's never a one-size-fits-all technology to fit every single use case that we have. So what we're thinking about are things like, what is the scope of our analytics decision and what are the actions that we need to take? What's the query complexity and the amount of data that's being processed in each of these transactions? Are we writing large ad hoc SQL queries, or do we want real-time analytics on all of the decisions that we're making? What's the diversity of our data sources? Do we have 1 billion different data sources? Are we pulling things from Salesforce? Are we pulling things from MongoDB or Snowflake and trying to aggregate that all together? Or do we have a limited set of data sources that we need quick insights out of? What's the query latency requirements? Are we okay with waiting 5 minutes for a query? Or do we need that data every 10 seconds coming back? How fresh do we need the data to be? Is it very important that we know that an outage has happened in a certain region? Or are we just doing a trend analysis over time? And lastly, what is the concurrency and update frequency of our data? So is it updating all the time? Are we consistently writing metrics? Or are we just updating it in a batch job once every day? So when we think about these levels of operations, and if the scope of our analytics decision is closer to a per operation rather than a batch job, that's a great candidate for real-time analytics, right? Our query complexity, we know for our application was low. The diversity of data sources were in between S3, MongoDB. We know that we needed low query latency for our analytical queries and high data freshness. We needed that data to be immediately available. We also had a lot of people reading and a lot of writers to this data. So we really understood that this could be a really good optimal deployment for a real-time analytics use case.
Go back, sorry. Go back one. Oh. Thank you. Now, a couple of takeaways here, right? So we want to go ahead and now, for analytics, it's not just about running analytics on a broad set of data. It's about application-driven analytics and transactional analytics on data which is local and personal to the user. We gave you a couple of examples, like maybe Chris doesn't really care about Chai's energy, or Chai doesn't really care about Chris's energy. But in a way, data is very local to the user, right? I care about a price of a taxi here in New York City. I don't care about the price of a taxi over in Europe. Now, next is a little bit of a call to rethink. So some of the concepts that we've gone ahead and explained over to you here today. I encourage you to go ahead and take a look at your API calls, take a look at your methods of analysis today, and maybe work with us, right? How can you go ahead and incorporate the aggregation framework for extensive transformations? How can you go ahead and incorporate maybe Atlas Search for some Lucene-based transformations? How can you go ahead and incorporate time series and Atlas Data Federation to bring analytics really close to the users? And keep in mind, this is just insights on small batches of data. I don't have to go through an entire large set of data, digest it down to the last hour. Instead, I can do these calculations on my application and on my microservice right here. And I can also do it live without exporting it over to an OLAP layer. Next, last but not least, is that we all ultimately want to do this for our customers, for the experience of our product. We want to go ahead and protect production in a way, right? So any lift of off-shifting and really going left, well, you can go ahead and help your customers and help your analytics with user experience. We can support multiple patterns like the high concurrency, sharing of visualization, high efficient and throughput and storage. You can do multiple patterns without impact over to your stakeholders. So I hope this has been a really beneficial presentation for all of us here, and really hope that you guys took away something here. Chris and I are very, very excited to be able to present to everybody here, and we would really appreciate it if you can go ahead and just scan that QR code, give us some feedback, and once again, thank you so much.
And, hi. Do we have any questions for Chris and Chai? We get hand over the mic. Any question? Okay.
Hi, thank you so much I think it was insightful. A quick thing from my side was that Mongo Atlas, right? Does it have a live data pipe coming from MongoDB itself? It's all like a local storage as a warehouse product?
I'm sorry, I don't think the audio was a little bit unclear, but let me try to recap the question. I kind of understood it as, is the live data coming in from MongoDB itself or external sources?
Yeah.
Is that correct?
Yeah, that's right.
Okay, yeah. So in our example, the live data is coming in from external sources. So sensor readings that might be on different IoT data sensors and whatnot. So it's coming in from external sources. But the point is you can go ahead and do the analytics on data that's already in Mongo or external sources.
And the only thing to add there is kind of as you saw in the data federation portion, you can bring your own bucket. So if you do have Parquet files that you want to analyze alongside your sources, you can enrich that data source.
Any other questions? All right, thank you, Chris. Thank you, Chai. And on this stage, guys, we're going to have building a world-class security and governance team with our CISO, Chris Sudlow, if you guys want to stick around. And thank you, Chris and Chai.